Particle P of mass 4 kilograms is moving up a fixed rough plane at a constant speed of 16 meters per second under the action of a force of magnitude 36 newtons. The plane is inclined at 30 degrees to the horizontal. The force acts in the vertical plane containing the line of greatest slope of the plane through P, and acts at 30 degrees to the inclined plane, as shown in figure 2. The coefficient of friction between P and the plane is mu. Find the magnitude of the normal reaction between P and the plane, the value of mu. The force of magnitude 36 newtons is removed. Find the distance that P travels between the instant when the force is removed and the instant when it comes to rest. Okay, this is the situation we've got here then, and I've summarized it all here. So basically this 4 kilogram particle has a weight of 4g acting vertically downwards. We now have a reaction which I've already drawn in here, perpendicular to the slope. So we can draw this line through here. This is 30, this is 60. So this angle in here is 30. Okay, good. And then we've got a horizontal here, which we can just carry on. So if this is 30, then this is 30, isn't it? And then this vertical, so this in here is 30. So we're just putting some angles in to help us resolve the forces. Okay, so what angle is this? Well, there's a pair of straight lines here and here. This angle is 30, so also this one is 30. Now it's moving along with 16 constant speed, so its acceleration up the slope is 0. Okay, good. So that's what we've got then in terms of forces. So let's have a look at the normal reaction at P then. Part A. So let's resolve the forces in this direction then, and apply F equals ma. There's no acceleration, so the resultant force will be 0. So F equals ma gives then R minus 4g cos of the 30. Cos 30 is root 3 over 2, so put it in straight away, plus 36 newtons, isn't it? And the angle is 60, cos of 60, which is sine 30, which is a half. So those are the resultant force is 0. So R will equal then, this is 18, this is 2g, isn't it? Root 3. Move it over, 2g root 3, minus the 18 then, and that's the resultant force. So it's 2 times 9.8 times root 3 minus 18 decimal 15.95, so it's 15.9, and that's newtons, and that's 3 significant figures there. Okay, that's part A. Find mu, so let's resolve the forces along the line of greatest slope then, and apply F equals ma again. There's no acceleration because it's moving with a constant speed 16, so the resultant force again will be 0. So F equals ma along the line of greatest slope gives then 36 cos 30. 36 cosine 30 is root 3 over 2. So that's that force. Minus, there's a resistance force here acting along the line of greatest slope. This is mu r, isn't it? Minus mu r then. R is the 15.9, but I'm going to use a more accurate version here, 15.948. So I'll put that down here, minus mu r. And then we've also got another force, so it's 36 cos 30 minus mu r minus 4g cos of this angle. This is 30, so this is 60. 4g cos 60 minus 4g cos 60 is sine 30, which is a half. So it's 4g times a half. These are the forces then, equals 0. So we should be able to get mu now. Let's move mu over there. mu times the 15.948 is equal to, so I've moved this over the other side of the equals, and it's going to be 18 root 3 here minus 2g. So mu is equal to 18 root 3 minus 2g over this 15.948 equals. So I've got this in answer in the calculator, haven't I? So let's just do this divided by ants. 18 root 3 then, the square root of 3, minus 2 times 9.8. Now we want to put that all in a bracket, don't we? Because we don't want to press answer, because we're going to divide by the answer that we've got in memory. So there's our top number. Divide by answer. 0.7259, 0.7259, and so on, which equals 0.726. That's the three significant figures. You can write it like so. There's mu. Okay, so we've got mu there, which we were asked to find in part B. Okay, part C, find how far P moves. Okay, we're told that the 36 Newton force is removed. So after that force is removed then in part C, so after we see that after the force is removed, we see that, let's look at this direction. Here, we simply get R is the normal reaction is equal to 4g cos 30, don't we? So again, F equals ma. R minus 4g cos 30 root 3 over 2 equals 0. So that tells us R is equal to 2g root 3. So there's our reaction force, newtons. Let's just remind ourselves that that's the case. This has now disappeared, so we simply have R minus 4g resolving in this direction. 4g cos 30, which is 4g root 3 over 2, which is 2g root 3. So that's that one. Now we go along the plane then. So in this direction now. So we've got no force up the plane, but we've got a minus mu r, which is 2g root 3, acting downwards, minus the 4g weight, and the component is cos 60, which is over 2, sine 30, so that's a half. Minus this is equal to mass times the acceleration now in this case. So what do we see then? Mu is 0.726, and so the acceleration then is equal to, divide by 4 all the way through, minus g root 3 times mu, I'm dividing this by 4 so there'll be a 2 underneath, minus g over 2, isn't it? Divide by 4, this will cancel, is equal to the acceleration. So let's just work out the acceleration then. Mu is in the calculator. So times by g times by root 3 over 2 times by 9.8 times by root 3, come outside and divide by 2. So that's this first number equals minus, they're all minuses, but we've got a plus here for this value. So let's just add on g over 2 plus 9.8 divided by 2. That's the total number, 11.0608 with a minus. So there's the acceleration, meters per second. So that's the acceleration. So we now know the acceleration. So v squared equals u squared. The final velocity is 0. The initial velocity is 16 plus 2as. We now know the acceleration, so we can work out. So this equation then gives 0 squared is 0, 16 squared plus 2as a times s. So that tells us then that s is equal to minus 16 squared, which is minus 256, and then the 2a can go from times to divide over 2a. So s is equal to then minus 256, 128, sorry, divided by 2 top and bottom, minus 128 over a is equal to, so that again that's in as answer. So 128 divided by answer then, and it's a minus. But we've actually got the positive here, haven't we, already? So it's 128 divided by answer, 11.57, which is equal to 11.5 meters to 3 significant figures. So that's the distance moved up the slope. Oops, just one little tiny change here. 11.57, the 5 rounds up to a 6, doesn't it? So it's 11.6 to 3 significant figures. Let's just put that in there.